For our next example here, you can see we've got a 4-carbon chain. And you can see it doesn't matter whether we number it left to right or right to left, we're still going to have a methyl group on number 3 and on number 2. So how do we name this? Well, in this particular case, we've got a methyl group at 2, and we've got a methyl group at 3. So because they're 2, it's dimethyl. Dimethylbutane. Yet again, in this case, we've got 3, 4, 5, 6. So therefore, we know we've got a hexane. And we can see there's a methyl group at 3. So therefore, our final answer is going to be 3, 3 dimethyl. And yet again, one word. So every substituent must get its own number. So this one's a particularly tricky one. So take a moment and see if you can figure it out. So hit pause. Okay. In this particular case, if we number from left to right, we can see we've got 10 chains, which makes it a nonane. And if we establish that, then therefore we've got one at 3, 4, and 8, which makes it a 3, 4, 8 trimethyl nonane. So I may ask you to give you the words, and you need to draw the picture. So in this particular case, we know we've got a pentane. So if we've got a pentane, therefore we're going to have 5 carbons. And on the third one, we're going to have an ethyl group. And we're also going to have a methyl group. So now we can just go ahead and put hydrogens in at the rest of those places. For our next example right here, we're going to draw a structural diagram for 2-methylheptane. So hit pause in the video, try it yourself, and then come back. So because it's heptane, that means we've got a 7-carbon chain. Now, we know the second group has to have a methyl group. Does it matter if I put it here or put it here? It doesn't matter, because both will be the same. So we're going to put our C here, and then we'll simply fill in the rest of our hydrogens. So there's our final answer. Now, in terms of physical properties, they tend to be nonpolar. Because they're nonpolar, they're non-soluble in water. Now, in terms of their boiling point, if you have 1 to 4 carbons, they tend to be below 30 degrees. So therefore, that's why propane is a gas. Now, if we've got somewhere between 5 and 16 carbons, well, then it's going to have a boiling range between 330 to 275. These are liquids. The example I can think of off the top of my head is octane, which is one of the hydrocarbons that's in our gasoline. Now, if we get between 16 to 22 carbons, we get a really higher boiling range, which is used in furnace oil. If we got over 18, we have a very high boiling point range. So this is where it tends to be semi-solid, and the example of this would be candles. Now, if we've got over 26 carbons, then we've got a very high boiling range. And this is an example of things that are involved in asphalts and paving.